Okay, welcome everybody to another episode of Morelia Python Radio. This is episode 559, and we are here with Dale DaNardo. We're going to be talking about python eggs, what's going on with the female when she's about to lay those eggs, and everything in between. Yeah, I think this will be a good one. And I don't know, Owen, do you have anything you want to hit on, or we just get right into it?
Lucas is here. Say
hello.
Hi, Lucas.
Yes.
Okay,
hello. Yes.
Have to throw that in there as well. I didn't forget you, Lucas, because I care. Other
I
people
just assumed that they would see him on.
I don't really know.
Yeah.
Well,
good.
Yeah.
So,
happy to be
Lucas.
here. Dale, we've had the pleasure of chatting once before. We have a common friend in Todd Trowbridge who introduced us, and I'm definitely a fan of his work at Arizona State University, and hope I can help contribute to the conversation.
I'm sure you will.
That's why we bring him. Yeah,
he's the smart one of the group.
Good intern. Good. So no, I got nothing. I'm just
okay.
Yeah,
let's just get into it.
Yeah.
All right. Dale, welcome to Morelia Python Radio. Maybe you could just start by telling us a little bit about yourself. How did you get into reptiles and what you do with reptiles currently?
Well, I think like most of us, or a lot of us, getting into reptiles happen about birth. It's like you wake up and you just all of a sudden chasing, grabbing snakes, picking them up. You don't even know what you're doing. It's just, I think for a lot of people, it's just the ability to actually hold the animal. Like birders, they just get to watch or hear. It's for some people that's okay, but how many herpers just want to watch or and nothing to hear? So,
yeah, I know.
So I was always interested, and I'm to this day. My brother always says, you still do what you did when you were 6 years old, and I said some of that's true. I'm still chasing snakes and playing with snakes, but a little more complicated nowadays with research. So I went into school, and I'm a veterinarian, but also have a PhD and pretty much a environmental physiologist. So I'm interested in how animals cope with environmental challenges, particularly resource limitations, things like energy limitations, water limitations, and of course thermal limitations, too cold, too warm, and the process there. And we've been working in terms of from the Python world. I've been using children's pythons for about 25 years because they're like the little lab mouse of snakes in terms of ability to breed and maintain and keep them, unlike the typical breeder that has all these different kinds of cages and has different species and different things in there, and they do different things with each one. Mine's about repetition. It's about having large numbers, all the same cages, everything's the same except for whatever variable we want to manipulate. So we can learn about these. And one of the big things we got into was studying initially. A lot was studying endothermy and the shivering they do, and basically documented that it's actually very few pythons that produce any significant amount of heat, even though it's thought that pythons across the board, it's basically 3 species. It all depends on who you talk to and how much you've split things up in terms of species. But a very small percentage of the ones looked at have been are endothermic. And then we also got into the parental care side of things, and to think that reptiles are parental care. But these snakes aren't just coiled on their eggs to protect them. They do a lot to regulate gas exchange with these eggs and water loss from these eggs. So it's been pretty exciting, and we use them a lot again to look at effects of things like hydration state, because a lot of pythons you think are tropical and they're just in this warm, wet place, but in reality a lot of them are in these wet, dry forests where there's a long dry season, and a lot of these snakes breed, and females are on the eggs during the dry season, so that hatchlings come out right at the beginning of the wet, and so they get the longest possible time to feed. So they're really a good animal to look at to see how hydration state impacts organisms and kind of the mechanisms they have to mitigate any effects, both. And we look at how it affects the female as well as the impact on the eggs, and how much she tries to mitigate impact on her eggs and sort of take the brunt of any impacts. So that's what we do and been doing for 2.5 decades or whatever, 3 decades. So feels like yesterday I started, but it's just exciting because it's always something new, and it's always fun talking to breeders, because breeders are the best at breeding these animals and look at things. But like I said, a lot of times breeders see things and they make conclusions without actually, carefully getting data. So the combination is really nice that I get ideas and share my results, and then we can put it in a control setting and really use it not to just learn about how to breed snakes, but using snake, because I can't get money funding to, grants to breed snakes. It just doesn't. It's hard to do. I'm just doing it as a hobby, right? To make a lot of money. But what I can do, though, is use them to convince people that they're a good study system for looking at things like parental trade-offs, like the cost to a parent versus cost to offspring, or offspring have a lot of demands. They need protection, they need food, they need gas exchange, they need things, and the female has to provide these. Or in some species, like birds, it's two parents. But you can't do them all the same. If you're sitting on your eggs, you're not collecting food for the eggs. If you're a bird, let's think about that.
Right.
So there's a trade-off. Female has to make decisions of what to do when to optimize that parental care of the offspring. So, and with snakes, it works really well because they're doing everything. These pythons do everything in a small space. They don't leave their eggs to go forage or do something. They're actually there, but they are doing things. They're having behaviors that we have identified that differentially affect the egg environment.
Does that change throughout incubation of what she's trying to take care of or manipulate?
Well, the biggest change that occurs that they need to address is that these embryos, when they're in the egg, first of all, about a third of the development of pythons occurs inside the female. So those eggs in the female, it's unlike a bird egg, which comes out and no development's really happened. Most reptiles are about 20, 25%, but pythons are about a third of their development. So a lot of times you can screw it up even before the eggs are out, in terms of you can screw up the eggs if your female doesn't have the right environment. Especially, you don't have to worry about moisture and all that because females, it's a moist environment inside her. But, temperature regulation is real critical during that time. But
I think I've messed that up a few times.
Yeah. I always get bad eggs. It's like, it must be infertility. Well, but if you see like the little vessel there or something, and then it got fertile, it died because it didn't have the proper
something else went. Yeah.
Something inside of mom. Yeah.
But the thing that has to be considered, whether they're live bearing or egg laying animals, is embryos have relatively low oxygen uptake, low metabolism until the last week or so, 10 days of development prior to hatching. If we're just talking about python eggs, and that change means now you have to get more oxygen to those eggs, to those embryos in the egg. And so you've got a shell to deal with, which is a barrier. Then you have a mom around that clutch, which is a barrier. And the other one that we've never looked at, always curious, is for pythons, especially all snakes, but especially pythons, how closely they stick together. For a lot of them, they have their siblings that are also barriers to oxygen move. If you're an egg in the middle of a clutch, you're mostly separated. Gases have to go either through those little cracks or through, the other eggs. There has to be a cost to being a middle egg type of thing. Yeah. Even though we see hatching success pretty similar, there is a benefit. You get less oxygen, but you lose less water too because you're surrounded. But anyhow, so this metabolism goes up at the end, so we have to have adjustments, and we've documented adjustments at both sides. One is the permeability of the egg is reduced. And anybody that's bred pythons, they're about to hatch when
condensation on the egg
in, and all of a sudden condensation all over the cage, right? You go, okay, they're about to hatch. Well, why does that occur? Why is that condensation occurring? Well, all of a sudden the shell is thinning, and with the thinning of the shell, it's allowing more oxygen to fuel the metabolism of these embryos. But also, water is also a gas, water vapor. And so if oxygen can now move through the shell more readily, so can the water. But at that point, the snake has a lot of this water already internally, right? It's not egg yolk and egg fluids. And so at that point, these eggs can cave, and that's fine. If you have eggs caving early, that's problematic.
Not good.
We don't get them to go back up. But late on, we all know that they sink, then you get condensation, and you're all excited. But soon you're going to get some hatchlings. So the egg makes an adjustment. The embryo itself, by thinning the eggshell, and we've shown that we've taken out thick eggshells and put them in artificially and looked at passage of water and stuff through these. But then the female also, because she's coiled around them, and unlike a bird nest, birds make a nest and they sit on the eggs, but their nest is porous. A lot of air gets through those twigs and stuff. So those eggs are exposed to normal oxygen concentrations. Whereas we've shown that pythons coil so tightly around eggs. In fact, you can pick up sometimes a children's python, you pick it up, coil around, and you can't see any eggs.
Mm-hmm.
Even though the bottom closed it off. That's not common. Usually it's more of a honeycomb type, a
beehive.
But they tighten them. We've shown that actually not only lowers the oxygen concentration among the clutch, but actually to a point that affects development, affects their heart development, affects their metabolic rate. And so coiling around the eggs is not a free thing for the embryos, but it's better to be a little oxygen depleted than to desiccate. Yeah. Because as you allow, if you take, I don't know if you guys have done, but if you ever take a python egg and you put it on a scale and you just bored, you just recently watched some grass grow, but you want something a little more exciting. The next thing, you could put a python egg on a scale and you could watch the weight drop over time. It doesn't take long. 10 minutes, you'll watch it lose as it's just dissipating. You do that with a colubrid egg, you don't see that as much. And so that's another question. Like, what came first? Coiling around the eggs to prevent that water loss through these very porous eggs, or the eggs became very porous because mom helps me protect from water loss. She's surrounding me, so I don't have to worry about that. But I do have to worry. I do need to be thin to allow gas exchange in this depleted oxygen environment. So it's like chicken or the egg. Well, this is the python, the female python of the egg brooding versus, the eggshell. So it really is, there are all these questions of how they're dealing with it. But the female will also change when the female's tightly coiled. If you're bored, even if you're bored of watching the egg lose weight, the next more exciting thing you can do, you have to be careful because this gets really exciting. Actually watch the female. She coils very tightly with her head sealed over the eggs. You can't see the eggs. And about every 10 minutes or so, she'll move her head to the side and kind of wiggle her things. And then for about a minute, and then she'll cover it up again. And people go, oh, she's just stretching or not. But by doing that, all of a sudden you get this enormous efflux of CO2 and water from the clutch and an increased oxygen depletion coming through things. It's basically they're kind of ventilating their eggs. Yeah. And then even less frequently, they have what we call an exploratory. The female will not only just move her head, but she'll start ducking her head between the eggs and the shell. Between the eggs and her body to really explain that. What she's doing, we assume she's assessing the environment. Is it getting too wet in here? Do I have a bad egg? And, if it's bad eggs that aren't stuck, they do kick them out a lot, but oftentimes they're stuck to things. So, but they'll do this exploratory behavior, but just this opening and closing where they just move their head to ventilate these eggs, they increase the frequency of that as it gets toward the end of development. So, but they only do that if it's in a moist environment. If we put them in a low humidity environment, they keep it at the low rate.
They're around it.
My eggs desiccate, they're dead. If they're low oxygen, they're going to take longer to develop, but they'll come out. And like I said, we see things like enlarged hearts from embryos from oxygen contents of eggs. But once they hatch and they've been in normal air, the development's dynamic, and so they can readjust. And the hearts actually get back to the same size as control animals, eggs that you develop, outside the female. We didn't do it female, and we're surrounded by a female or not. We just did it under conditions where we gave them the oxygen concentration we know when they're surrounded by mom, the oxygen concentration we know when they're surrounded by mom, just always surrounded by mom, but she ventilates periodically by moving, and then just fully exposed. So, they are different levels, and we don't see changes. We see differences in the ones that are coiled. So that it's not free. The mom's providing a lot to those embryos, but there is a cost. And I always tell my students, everything has costs and benefits. There's nothing that's, even in evolution, it's not like, they evolved this and that just made them better. It made them better. But some things are better and other things are worse. You think about highly specialized anteaters, highly specialized tongues to get ants. They're better at catching ants, but they really suck at catching anything else.
It's that,
right? It's like
there's no such thing as solutions, just trade-offs, right?
Yeah.
Exactly.
Oh, yeah.
And you can say it's a solution because it enables you to do better because of the environment you're in, but it also kind of pigeonholes you into a lifestyle, or as you develop these more effectiveness at doing particular things, you become less, jack of all trades, master of none. And if there's a lot of competition, you want to be a master, and therefore you lose this ability to adapt. But, we see both. We see animals like, coyotes that are extremely adaptable to anything, and they maintain that adaptability. And we see animals, like I said, the anteater that, is dependent on ants. It's whereas coyotes, even if they did eat ants or something, or any food that coyotes eat, if you took it away from them, they have other things they can eat.
Find another one, yeah.
So it's just different evolution trajectories that enabled these animals to be more successful overall, but there's no perfect situation. There's no perfect solution. The same thing is true with these pythons and whether they brood their eggs or not.
I suppose you could even extrapolate that concept all the way zoomed out to the difference between egg layers and live bearers in the first place. Do you have any thoughts on why this group of snakes ended up being a group that lays eggs, rather like what is the advantage of going through all of what you just explained versus just holding them in and pooping out live worms?
No, I mean, it's a great question because, like I said, a third of the development is inside moms. Yeah. That's basically live bearing for the first third. And then the rest of it, instead of laying it and running away, then they're still with the eggs until hatching. So they're completely investing. So why not just, like you said, keep them in and poop out babies? And there's probably...
I'm a scientist.
That's a formal word.
It works, yeah.
Right. Well, we could use other words, but these 4-letter S words get us, a problem. But, so one of the problems is, again, in order to have live babies, you've got to be able to provide oxygen in large amounts for that latter part of development, that they're low and then all of a sudden they have this high demand. And when it's inside the female, that can be trickier to do that. And so, and viviparities evolved probably 120 times in squamates and lizards and snakes. So it's evolved readily. And so, but there's that potential benefit of doing it. But there's a cost. And one of the costs is, how do I provide enough oxygen for the late part of development? Early on, holding them on longer, they still have low metabolism, it's not a big deal. But so it could be that pythons, and again, there's no perfect solution. So they said, okay, we can get all the benefits of being viviparous, but instead of developing better oxygen delivery to eggs, we can develop brooding. And then we have brooding. And so it's, again, achieving a high level of parental care, because having live babies is parental care. It's you're taking care of the offspring. It's not voluntary. You got to go through with it. But that may be one advantage of having a clutch. And we've looked at water pythons up in Northern Territory of Australia, and notice that if you have water pythons and when they go to lay their eggs, and Rick Shine did a study years ago, and then we repeated it to look at slightly different things, but did it again, and both of us showed that with water pythons, some of the females abandon their eggs in about the first 10 days.
Right.
And if you go more than 10 days, I don't remember the exact number, but if you go more than, that's why we publish this stuff. It's not for you, though. You guys know, so I can remember what it is.
You read it, yeah.
But
the hell did it?
So
that study is a favorite of the program.
But it's 10 days or the entire time. There's no in between. Females that left, they left early. And if they didn't leave in 10 days, they stuck it out for the whole 50-something days. And the advantage of leaving the eggs is that for these water pythons, they feed mostly on these dusky rats. Right at the beginning of the monsoon, there's a big surge in the presence of these rats. So if you're sticking on these eggs for 50 days, it's only 50 days of 12 months, but it's 50 days out of what is probably a 3 to 4 month feeding period. So you're losing at least half to 2/3 of your feeding opportunities. It doesn't cost you much to stay coiled on the eggs, but you're losing the opportunity to gain the energy. Those eggs weigh about 1/3 of the female's body mass, right? So she needs to gain more mass, and she's sitting on these eggs instead of foraging. So it enables a choice. It provides some flexibility that I'll stay on my eggs or I'll leave them. And if the conditions are just right for the eggs, if the conditions are perfect, females abandon their eggs. Like if they lay these eggs in these termite mounds, which Rick Shine has shown. If they lay them in these root bowls where conditions are pretty good but not perfect, females stay on them and just provide that extra buffering that they can do to the environmental conditions. If they choose so we both showed that middle one. They stay on them if they're in this good but not perfect world. If they're in a perfect world, like in these monitor or these termite nests, which the problem with that is they get raided by monitor lizards, dig them up easily and lose a lot of eggs, but females abandon it. But if you have the other thing where they lay in they choose poorly, and they lay in a bad place. It's cool down there, whatever. Then they can just leave. They'll eat for those 10 days, and then they can go feed. Okay? I made a mistake, but I'm not paying for it for another 2 months because I have to give birth to these very poor quality offspring if they even survive. Right. Which is, hey, I can cut my losses and now go feed. So maybe I can breed probably not the next year, but in 2 years instead of 3 type of thing. So that laying of the eggs may be required because they can't provide enough oxygen to those embryos. Instead of developing that adaptation, they develop this parental care. Mm-hmm. And it could be actually selected for because it allows choice. And we know, at least in water pythons, that they have this choice. And in both of them, they did this exact same thing. They spend about a week to 10 days assessing their decision of where they laid their eggs. And at 10 days, they say, let's stick with it, or let's cut our losses. And, in other species, like the reason I use children's python, one is they're small, they're very easy to breed, but they are dedicated mothers. I can take a children's python off her eggs. I can collect blood from her heart. I can put her in a respirometry chamber, measure her oxygen consumption. I can put her eggs in a respirometry chamber. After a few hours, I throw them back together, and she coils right back on. And then we have things like we did a big comparative looking at endothermy, ability to prove heat. And so I had over 200 adult pythons. It sucked. I had all this stuff. And more than I'm trying to breed pythons and actually collect data. But things like, and then you finally breed them, and some of them, wombas, which are pretty easy to breed, but you pick up the container that she's wrapped in her eggs on, because we don't, not fancy aquarium, we confine them. Mm-hmm. Once you do that, she leaves them and she won't go back on. And we had, over and over again. So we just had to actually, before they lay, we had to put them in the respirometry room all set up. So she lays there and we never have to pick her up, because whereas, I can almost juggle the children's pythons. So, we just we looked at all these different species, but we've done so much more. We got so much more data than with children's pythons. So we've continued using them because they're just such a good system. Again, it's not about learning. That's your job, Owen, to breed all these different pythons. My job is to learn and understand what's going on and trying to understand. And hopefully, from what we understand, which is a broader understanding of trade-offs and parental care, also provides value, in the breeding side of things, because it's a good combination. This anecdotal experiences, hunches that, breeders get from just their dedication to it and their observation value, combining it with, we've shown that, but in reality, it's actually this that's happening. And sometimes it doesn't matter what the explanation is, as long as you know what to do. Other times, if you have the wrong explanation, you take the wrong road. Right. Of what you want to do for the animal, you're actually making things worse when you think you're trying to make things better. Or if you're trying to breed things, you change 6 different things and it works. So for the rest of your life and everybody else's lives, they're going to do all 6 of those things when it may have been just one.
Yeah.
Right. No one's going to say, okay, let's figure out which one it is, right? Right. You know it works. Right. Don't change anything. Don't move anything. Just stick with those changes. So, hopefully it has value at the herpetoculture level. And like I said, I love chatting with people in herpetoculture, because in many ways, you guys are so much smarter than me. And in other ways, I'm so much smarter than you. And when we bring it together, it really is.
You actually start getting stuff done. Yeah, it's
so many researchers, or even zoos, the private breeders, or it's like private breeders know what they're doing because they're doing it. They're dedicated to it. It's the spare thing. They have most have a real job where they're trying to make a living breeding snakes. Right. It's better to have a real job.
Yeah.
Right. Either way, you're investing. It's your life. It's not like you work at a zoo and you have a paycheck coming in and you're trying. And zoos they need variety, and so they don't have 5, 6, 10 pairs, or for me 75 females at one time that you can do these adjustments. Yeah, we got it that high. Usually I was trying to keep it at 50 so I can have 4 groups of 12. I can do a 2x2 experiment. Okay. 48 females, and I like having a little more than that. It's not, of course, not everyone breeds, but with children's pythons, I get over 90% of them breeding every year. Yeah. Some close to 100% some days, some years.
Nice. I do have a story, and then maybe you can. I do have a question. All right. So my story is, the first time I tried to do maternal incubation was with a Papuan carpet python. And basically I kept putting the nest box, say, under the heat, and she would move the nest box to the point where
So you're saying she was smarter than you?
Yeah, she was 110%.
100%.
Sorry to interrupt.
So she kept moving it back to the spot. So finally I just sort of, and this was the first time I've ever bred pythons. And so my question is, how does the female go about, what is she doing to select for a nest site? Do we know that? Is there any theories on that?
Selection of the nest site, we're not sure. And that's, like I said, water pythons, some of them make mistakes. They choose the wrong place. Right. The ones with when they choose a termite mound versus these root bowls, they're both winners. It's just you abandon the one there's high mortality. You can abandon them, leave them alone, and they'll survive just fine and hatch, as long as monitor doesn't eat them, which happens often. So, but sometimes they check, they choose poorly and they have a wrong site. So it's not, but we do know that the way they're sensing whether they're in a good environment or not, it's not their body temperature. It's actually the temperature between the egg and her that drives the temperature that they'll regulate. And we've done this like with Burmese pythons, which, produce heat and generate it, but they're driven and they discern the heat not by how much they raise their body temperature, but they can sense that temperature of their belly against the eggs. And that's why I think a lot of these pythons, when they do this exploratory behavior, like I said, they're probably sensing humidity, they're sensing temperature, they're sensing a lot and making decisions. Now it's hard to move, that whole clutch, but in terms of choosing a good nest selection, I mean, that's deeply rooted ancestrally. I mean, almost all squamates do that, or at least all egg laying. But even most live-bearing squamates, we do a lot of rattlesnake work too. I know they're not Morelia, but
we still like rattlesnakes.
You like rattlesnakes?
Yeah, we still go looking for them.
But we've done a lot with them, and these females will move to what we call often rookeries. They're not bird rookeries with hundreds of thousands, but you can have 3 females that are and they're rattlesnakes, and they'll all lay in a common area. And so there's they're not doing it because I have people say, "Oh, they're probably sisters." It's like, yeah, I think they're all focused on what they need, and they all independently determine this is a good spot, and so they're there. But there is a lot of site selection is so grounded into, I think, squamates in general, reptiles in general, and birds even. And birds they control it a little more, but turtles, snakes, lizards, crocodilians, they all choose nest sites, and because it is tricky. Like, they sense the temperature of the nest and all that, but that's the temperature now.
Yeah.
What about the temperature tonight or a month from now? How do they know that this is that maybe the optimal temperature that you want your eggs to develop at means you want to look for a place to lay that's cooler than that, because as the summer warms up, you're going to get. I mean, these female, we don't know how. I mean, it's innate. They're not learning this. They're not reading about it, but they are, it's in it, but how is that journey? How is that decision made to find, that particular environmental condition that's going to make it? So we don't know much of, but we do. More of ours has been, after laying, looking at these adjustments in the females, sensing the environment and knowing whether to, especially these ones that produce heat, whether to produce more heat or not. But even the other ones, if you keep children's pythons warmer than they should be, not cooking them, but warm, they will loosen their coils dramatically. And because it's getting too hot, like I said, they favor water conservation over temperature and oxygen. Water conservation is the most, but if it's so hot, they know their eggs are going to cook. They just open up, and usually the eggs just shrivel out too over time. But they're trying to make that adjustment because they are recognizing that it's too hot of an environment.
Something's wrong. Yeah.
One of the things that.
Oh, go ahead.
Sorry, just real quick. One of the things that I've heard hobbyists kind of guess at is that they think when the mom is sticking her head into the coils, perhaps she's taking temperatures with the labial heat-seeking pits. It sounds like what you're saying is that the evidence suggests more that they're able to gauge that from the ventral scales directly.
It seems like they can sense, like you can sense heat on your skin, right?
Yes.
A stove or even just a warm thing versus a hot thing. And I think, eventually, because remember, when they coil on them, they're not just flat against the egg. They kind of, sometimes you don't coil a female, there's an egg stuck. If they're a separate egg, just trapped in there. So they have a lot of contact. So I do think they're sensing temperature. They can sense it from their belly.
Okay. So perhaps a bit of a misnomer there.
It's not the only way. I don't think they have to do that for sensing temperature. I think they may get an idea, but I think they have the temperature figured out. I think they're more down there saying, how humid is it? And their condensation is, python eggs extremely sensitive to condensation. You get a drop or two on them and boom, they're gone. Whereas you can take Kluber egg, drop it in the water, leave it there, pull it out, and they hatch.
Throw it, yeah.
College. I literally had these water-based incubators, and I was pulling one thing out, and I spilled the incubator, the little shoebox I had, and spilled it, and they went in the water. That to help keep the incubator constant temperature and humid. It's like they're all in there, and it's like I just pick them up, and every one of them hatch. You do that to a python, it's done. You might as well just crash them and
bye. Yeah,
go beat yourself for doing something stupid. But
when you were talking about the nest selection, the question that I was gonna, we've heard people say on the show that like you take like a Brettles python up in the trees, that they would have eggs already in the nest. that she's there. Is there any thought that they're returning to that same nest because of the idea that it was a good temperature and a good?
There is. I don't know if there's there's not really evidence that they return frequently in nests. I mean, even with these root bowl nests and these paper bark, the termite nests and these root bowls and the paper bark trees, females tend to repeatedly use whatever type of, not the same nest, but the type of, whether it's a termite. But that's also because of, there are areas where there's a lot more termite mounds and other areas where there aren't, right? And so it's not like, but they do document females that did move between the two and did it. But I'm not aware of I'm not saying it doesn't exist, but I'm not aware of a significant amount of data. Maybe, anecdotally, we found the snake in here twice. But if you follow 100 snakes around on successive clutches, do they ever go back to the same nest? I mean, that's be a lot of work. Right. But I don't know of any evidence that really suggests they'll go back to a place where it was a successful nest.
Gotcha.
Not saying it doesn't happen, just I don't know.
Right.
I think it would also kind of depend on their range too. Like we found Darwin carpets in the botanical gardens in Darwin, and it's like they had a really nice setup. So I don't imagine they'd be really going too far away from that enclosed garden area surrounded by city where food was coming available. So there might have been overlap just because these female carpets that live in the garden aren't going to go exploring.
But even for those females, are they going to go to the exact same spot?
Right.
Or are they just, and the odds are, if you're not, and you got to be careful when you're examining data. It's like, if you're in a place where they don't move around much because they have everything needed. And I truly believe home range size is dependent on, you want it as small as possible for the most part for females, but you've got to be as big to get your resources. So if you have a smaller home range where you can get all your resources, the odds of you using the same spot 2 years later is higher than if you have this enormous area that you cover because you're going to be in different areas. And, like I said, and we do have, like with the rattlesnakes, we do have rookery spaces that are used by different females. Like every year there'll be a female to there, but, not just the same female. And we've seen females that we know have nested out a rookery and next 2 years later or 3 years later are nesting in a different spot. And so I think they're
with I know this is rattlesnakes and not pythons, but do the rattlesnakes offspring return to those same rookeries at all? Has there been any studies with that?
There isn't, because that's a long investment. They be following snakes to see if they return.
Following a lot of baby snakes for a long time.
Right.
Yeah, most of the baby snakes are going to be killed and dead. But
all my ideas are impossible.
Cross that one off.
I don't think for the rattlesnakes live in the desert where you don't have a risk of freezing. It's like diamondbacks and we have, they're on the ground. They don't dent up much. You may get a few together, and then you go up to things like Arizona blacks before you even get up way in lotosis, high latitudes. But even you get a higher elevation, you get higher numbers of animals, and females tend to give birth where they overwinter, and the babies will stay in that area, and they'll overwinter in that same place. And that's kind of one way of ensuring that your offspring have a place. Right. Thought is you have insurance of a place, and female's not going to eat while she's got developing an offspring, so why go wandering all over the place? Might as well stay there. It's successful, and you'll see. And then in spring they'll emerge. In fact, this is the perfect time of year where females will be out, and all these babies will be around them. You have 3 females out on the ledge, and you have all these babies around them. So they can, and those are babies that were born in the previous fall. So that way, the female can by giving birth at the den site, they can not only take care of them then and ensure overwintering. They're not going to freeze, but also upon emergence, the female can still protect them until dispersal. So, it's just a lot of these questions are just basically impossible to answer because of
right.
Damn it, Eric!
And that's
I usually have the impossible
questions, and you go, but you can take that way we approach stuff like that. It's like we can't do that, but is there an experiment we can do in the lab that's going to tell us whether or not they return to similar spots or things like that. And it's just good. But that one's really tricky, and you'd have to have thousands of baby snakes initially to have dozens at best that make it to sexual maturity and are females. So you cut those dozens in half.
Right.
Half dozens.
I think. Yeah, I was going to say the other question I had while you were talking is you were talking about that there's this misconception that a lot of people think that all pythons go around the eggs and raise the temperature, thermogenesis, all that kind of stuff. But why is it that berms and, say, carpet pythons seem to be the ones that do it? Is there any thought to why? Is it
there is. There are thoughts on it. And I mean, all pythons that we know that people have had breed, female coils around the eggs. That seems to be consistent. It's not that, I had a female that ignored her eggs. But for a species, each species, that is an inherent thing that they do, is they coil in the eggs. But the only ones that are known, you can't say carpet pythons, because we've done jungle carpets. They don't do it. The ones that do it, the species that have done it is the Burmese python, Indian python, which is the same damn thing, basically. It was. Yeah. Now it's different. Right. And then you have the diamond python.
Okay.
And the Southwest carpet python have all been documented to do it.
God, that makes sense.
Really good documented to do it. Well, you think about, where do these occur? They are the species that are at the highest latitudes. Yep. Northern hemisphere, the Burmese and Indian, southern hemisphere, southwestern, and the diamond, which is in the southeast. They're the ones that are in the extremes. They're the ones that are environments that are the coolest. And so generating heat is a cost to it, right? You're going to burn a lot more calories. And so if you live in an environment where you can find a warm enough place where you don't have to shiver, why would you evolve this? Even if you could do this ability, even if it's in, and we know they could evolve it because these other pythons have, and they tend to be bigger ones, but there are a lot of pythons that are the size of Southwest or diamonds that don't do it. They're plenty big. Children's python, pygmy python, there's not a chance. There's just not enough energy stores there. But why, if you're in an environment where it never gets that cold, why ever invest in heat? Now you could keep maybe more precise, but it's not necessary. Why do it? Whereas if you're in these extremes latitudes, which are cooler, and they're not cold by any means, but they are cooler, that maybe there's a greater selection pressure to supplement heat to the offspring to buffer them against potential environmental cooling. Because it's not just coincidence that the majority haven't been looked at, but it's a handful. But we have data on ball pythons and water pythons and children's pythons and womas and
womas don't do anything right. Did you look at Brettles by chance?
No, we didn't. We didn't have Brettles. I would love to look at all the different Morelia and get an idea. We did Virtus, and they don't produce heat, which isn't surprising. They're in this hot place.
Right. I wonder if Morelia carinata.
That would be a very interesting one. But again, it is relatively low latitude,
right?
So Brettles. If you've been Alice Springs area. I don't know, when they're laying eggs, because it's cold in spring. It's very cold at night in the spring. But when are they laying, or if they're laying their eggs, it's about temperature. And plus they're laying them inside these tree trunks, which may be a really good buffer against environmental temperature. So, if there's the ability to have your eggs incubate without generating any heat for them, there's going to be selection for that. And if it involves choosing warm nests or the timing of when you lay your eggs, it's all going to be better than spending a lot of energy. Sorry about that.
I do have a question on that. So when you're looking at the species that did not produce heat in that study, I feel like a lot of the times you'll get the keeper anecdotally saying, well, I saw it wrapped around the eggs and it was twitching.
Yep.
Is that something that happens without the production of heat?
Well, again, the way we do it, the way we assessed it is we would basically take the female, put her at an optimal developmental temperature for her eggs, and look and measure her metabolic rate. So she's not generating any heat because they're cut. And then we put them at a lower body temperature. And in lower body temperature, her metabolism, if she doesn't produce heat, will go down because cooler temperature, they're not as warm, they're going to have lower metabolic rate. But if she has the ability or chooses to produce heat, her metabolism is going to go up when she's at a cooler temperature, which is exactly opposite at what you'd predict for any snake that you put at a cooler temperature. And so you don't just measure it once, and it's not just you see this occasional twitch. And we have data like ball pythons. They do a little warm. What was the other one we had? Can't can't think of offhand. But it was one of those species where there's some heat generated. They're doing a little heat, but it's not significant. They're not contributing. Right. They're not raising their metabolic rate. It's not dropping as much as you predict for how much cooler it is, but it's also not going up. It's not above where it was there. But it's not as low as it was. So there's some minor type of adjustments to it. So it's not that they don't, but it isn't sufficient enough to actually
do anything.
Thermoregulate the eggs.
So the folks that are at home listening, screaming at the radio that they saw their woma twitch. Yes, you may have.
You did.
But that doesn't mean that it is a facultative.
Yeah, and they can send all their complaints to Lucas.
Yeah. Yeah. That's where all the complaints go. Yeah.
But I mean, exactly. That it's not. I mean, that's just you have to see that. And then
nobody's calling them a liar.
The heat's being generated, because if you watch a snake, it only twitches occasionally. So it's like, is it just that occasional twitch that's producing those extra 3, 4, up to 7 degrees that a Burmese python can do? Or is it that they actually generate heat by being in tetany, constant contraction, which is muscle use, and the heat, and the twitch is just relax and start over again. Let's relax and start. So the twitch is actually the break. It's not the actual energy heat producer.
That makes a lot of sense.
No, and we tried to look at that a little bit, but you need some pretty fine thermocouples in the muscle beds to really see, and very quick reacting to see when that heat is more heat's being generated. So this odd twitch here, this twitch there is not going to heat the clutch. And it needs to be a regular twitching. And I always trying to stay away from, like, I call it thermogenesis, not shivering thermogenesis, because I'm not sure. We don't know really exactly how they're doing it and how much the shivering and twitching. It's not, it's more twitching, but it's just, if you really think of that those single twitches aren't there, especially when people say, I've seen my female twitch a few times. It's like, yeah, it's great, but I twitch a few times too, but I'm not trying to.
Right.
Yeah, that's fascinating. So I get what you're saying.
That's why we got numbers. I like quantitative evaluation. We see things, which makes us think about what to do and what we can do, but we want to figure out a way how we can take away our bias, or we see something, but is it sufficient enough? And what we're interested in is it enough to make a difference for anything?
Right.
Yeah, the oxygen suppression to the eggs when the female's coiled, is it significant to get a low critical oxygen tension, meaning you're going to reduce the metabolism of those embryos because the oxygen content's low? And, it's not just, we can find a statistical difference, but is it significant enough to influence the processes, in this case, healthy development of the eggs?
Right.
Okay.
Boom.
That's fascinating.
Yeah.
I love that stuff. Okay. What else do we have on our list? Let's do, I'm curious about, we're talking about some myths or things that people in herpetoculture may say, and then
myths in herpetoculture?
Never.
No.
Never.
No.
We did on a few.
With our codom species, yeah.
What about if an egg rolls?
Yes.
Is that immediate trouble?
For a turtle.
Wait, are you telling me I don't need to draw X's on X?
If you want to draw an X, keep them vertical. Why not? It doesn't harm them. They're not birds where they need to roll them. But the difference is turtle embryos attach to the cell wall. Mm-hmm. And so when you roll them, all of a sudden you end up suffocating.
Smothering the baby.
Their yolk, based on it. Whereas when you turn a snake egg, the embryo actually rotates up. And so you can turn it, but they typically always are going to rotate up. Initially you'll see that fertilization spot or egg spot, whatever you want, where you see a little ring and all the embryos and that's the starting of it. But as that embryo grows, it is more movable. So in squamates, rolling them does not seem to be an issue. There's no evidence I know of rolling the egg. Now, I'm not saying put them in a little roller and constantly.
right. I'm not saying go in there.
Doing this,
not like the bingo machine.
But like one of those bingo.
Yeah, just constantly turning the eggs. It's the best way.
On a little generator with a fan belt. Yeah,
that might be how you get the jag.
But no, I mean, I am not aware of any studies that have shown that rotating a squamate egg has a big effect. And anecdotally, we've had a lot of them just roll over and oops. And even turtle eggs, you can roll them all you want in the first few days because they haven't attached yet. And that makes sense because when she lays the eggs, it plops them in, and she rolling all over but once it sits and the embryo attaches, then rotating that egg. And why not? I mean, in the wild, they don't get rotated. The only time they get rotated in the wild after, a day would be a predator, and then by then they're being eaten. So it doesn't really matter if you die from, you're not going to die from being rotated because you've been eaten before you do that.
Exactly.
What would be some of the things that hobbyists do consistently wrong or have wrong, or the idea that they have are wrong when it comes to python eggs or python egg incubation? Artificial incubation.
I mean, the one thing I don't know, it's not wrong, but one thing I don't understand is like people go, I really like to maternally incubate the eggs. And my big thing is, what the heck? Why?
Thank you, God.
Because you're instead of in some sort of, again, if you put them in crappy little incubator setups, you might as well leave them. But if you put together a nice setup where the eggs, you have it completely controlled. Oxygen delivery to those eggs is much better. And we've shown when the female's coiled around it, they get below critical oxygen tension. Those embryos are being compromised. Now they develop and they get through it just fine. But there are non-clinical effects that we can measure on these to doing that. So if you do them away from the female, one is you don't have to worry about the oxygen suppression. Two is you can control the environment very carefully. Three is you can see the eggs. So if one starts riding, you can modify. If you see them starting to cave in, you can do it when the female's on it. You don't see what's going on. You're just trusting her. And, she knows what to do, but she's evolved to do it in a rainforest, right? Not in your cage. And then the other advantage of doing it is if you take the female off, you can start feeding the female again. In the wild, they don't breed every year.
You are making Owen so
this is
happy.
Music to my ears. I've been rallying against this argument for 13
I did send
goddamn
you
years.
The bank account, right? That you need
And we'll talk off air. How much do I have to bribe?
I don't get it. I mean, you can have success that way, but again, success hatching versus the hatching quality. We've had eggs that we've split eggs into different things and come and have the same clutch. And you can see, babies come out feeding like crazy if they're really in these optimal environments. If you don't it, they're fine. They'll feed, but they're more finicky. We look at strike force. We looked at numbers of strikes. To me, a baby snake that strikes is the best baby. Those are the ones that feed well. Those are the ones, and they'll get over it. They're just we're the ones that just sit there and go, "Oh, he's so cute. He's calm." It's like, I'm sitting thinking, but he wants to be striking. Maybe he just doesn't have the strength and stuff to do it. So we have different. We do swim speed, and a lot of pythons don't swim, but nice thing, put in the water, they do swim, and you can control it better to get them consistently swim. If they're on land, they'll stop every 2 seconds to quit pushing me. So we look at these assessments. Doesn't mean they're not going to survive. It just means chances of survivorship, especially in the wild, is going to be reduced. And so you don't want to just hatch an egg. You want to hatch the highest quality egg you can hatch. Some of that's due to mom and dad's genetics. But in my opinion, activity, more of it's due on how you handle that female during that first third of incubation and how you treated those eggs. Because if you don't believe me, take a clutch take the most valuable clutch you get, divide it up into thirds, and put it under different conditions. And I guarantee you'll have different hatching successes and you'll have different offspring quality if you do that. So people always blame, it's inbreeding. It's like inbreeding. You bred them one. They're siblings. 2 wildcat hens that produce siblings. Breeding those siblings, unless there's a really strange gene out there in the wild, which these common recessive genes are really common in domestic species and humans, but in the wild, it's not as bad. I mean, you want to try and have as broad of a gene pool as possible, but it's amazing how quickly people want to change. It's inbreeding that did this, and because I got 2 snakes, and they're not siblings, but their parents are siblings to the parents. It's like, come on. There are and especially python eggs. Like I said, colubrid eggs, it's almost like you can do anything to them. Something about python eggs are more sensitive. And again, is that why parental care evolved? Because for some reason they developed sensitive eggs? Or is it because mom's taking care of them? It's like a spoiled brat. It's a person. Right. They're incompetent of doing almost anything. I had a student that, he'd never done chores. Like, have you ever washed the dishes? And he said, no. And I said, never. And he goes, Oh, well, yeah. I take my plate to the sink. This is a 21-year-old kid.
And the sink fairy cleans it for you, right?
I got a mom.
Yeah.
Jesus. You get that.
The dining hall is not helping him learn.
Yeah, no.
Yeah. And I'm not saying you need to make your snakes wash dishes, but
toughen them a little bit. But
you got to pay attention to. You can't control necessarily the genetic side. That's mom and dad. You can control, and also the environment. Control the environment that these adults are, especially males, are developing sperm. If you get a male too hot when their testes or when they have active sperm, you're going to have you're going to kill sperm or you're going to deplete mobility. And reduced mobility means you get reduced fertility. And again, you blame the snake when usually you got to look in the mirror and figure out what you did. And the thing is, it's not all about. Everybody thinks it's like, oh, I got these eggs, and it's everything that's going to succeed or not is when based on how I incubate the eggs. Yes, that's important, but it's also the female when she has actual eggs, developing embryos in it. Female as she's producing her follicles. Male as he's producing sperm or maintaining sperm. All those steps are critical, and I think some people just wait too long before they worry about being real careful.
Eggs are like step 5 and sitting at like step 1.
Yeah, and then you got to feed the thing, right?
Yeah.
Right.
A lot of that is, again, it's not just they hatched or didn't hatch, it's that quality of babies. Because we know we've all had clutches that, they just they've changed things, and you see consistencies, and
Is there something that links incubation or like to yolk absorption? Like, if we kind of think maybe it could be temperature, oxygen exchange, something like that? Have you seen anything that might kind of point us in a direction with that?
When you see oftentimes dehydrated snakes, it's real tricky because if you have a female that you restrict water to, because and which I call it really the control group, because they're doing this in the dry season and they're normally not getting water. They don't have a water bowl available. But if you do that, they get dehydrated and they produce eggs that are lighter and also have an increased osmolality. The embryo is even dehydrated as it develops. That's early on, first weeks. But we also know these parchment-shelled eggs can absorb a lot of water. So female laying an egg that's slightly dehydrated, somewhat dehydrated, can fix that by choosing a spot where the egg can take up water. But if the eggs are raised, if they kind of feel dry, or they're in a desiccated environment, or you have too dry of conditions, eggs gave early, embryo comes out. A lot of times you'll see a lot of residual yolk in the egg that the baby did not absorb that. And when you think about it, what percent of almost any animal, including a snake, is water?
70-something.
Let's see what he said.
About 70, 75?
There you go. He is the smart one. 70 to 75. Yeah. Every animal, every terrestrial animal, you get things like jellyfish that are just goo. But
I love jellyfish.
And for yolk is only about 40 to 45% water. Okay. So if you're going to convert yolk to baby, what do you have to add? You got to add water.
Yeah.
Because as you mobilize some of this yolk, it's only 45% water. To turn that into tissue, you got to do a lot, turn that into tissue, but it's going to require more water to do that. So if you had limited water availability, you're in a dehydrated environment, you can't utilize all that yolk. Now, one thing they do is you get a lot of these, they get these little yolk plugs still inside of them when they're born, right? They're born with a reserve of yolk that they absorb it and they leave it in the body. And one of the ideas behind that is a couple things, like some people, it's energy that they can use until they find food. They grow during that time, first 2 weeks, they'll grow if you don't feed them. And that's the result of mobilizing that yolk, high energy yolk, into lower energy tissue in general. But also they can gain weight too. Well, how do they gain weight when they're just taking the yolk in their body and turning it into tissue? Well, they're drinking. They have to drink. And one of the things we haven't done, we've tried, is like, if you deprive the babies of drinking, do they grow less over those first 2 weeks? Because they can't, and do they leave some of that residual yolk that they can't do it? So I think a lot of residual yolk is more related to water availability to the offspring, unless you really, again, temperature can mess up everything. Temperature is a potent influence. So for most people, you can create an environment, a pretty constant temperature environment for these guys. And, some people want to fluctuate it, but I think for most of these pythons, the nights and the days are not. Like, I was just in, Cape York. Day and night was like 2 degrees difference. Right? You don't have to worry about nighttime cooling, during
right.
So
while we're on the subject of yolk, if I may ask a more niche question, what do you think is going on with the baby black-headed pythons in the hobby that come out with ungodly yolk bellies, like concerningly large yolk bellies? Do you think that is supposed to be that way? Or do you think that there's a connection between maybe feeding a reptile specialist mammals and then the yolk being more rich as a result or something like that?
I mean, blackheads, they're a mess. Yeah, I don't think it's I mean, in terms of keeping them and trying to breed them, it's like every step of the way. I mean, the one thing females do is they yolk up. They always start their follicles and they'll get big follicles, but get them to ovulate, get them to lay good eggs, get them the good eggs to hatch, and get these hatchlings that don't have these. I don't think these large yolk masses are at all normal because this animal's got to slither around.
Yeah.
In the wild. They can't just,
You've seen what I'm talking about, right?
Or,
Yeah.
You've seen what I'm referencing.
Oh, I know exactly.
Oh, yeah.
Yeah. But, in captivity, you can keep them in a little deli cup or a big deli cup until they absorb it all. But in the wild, they've got to slither around or else they're just going to be food for the first bird or mouse or anything that comes by.
Yeah.
So that can't be a normal thing to be that full. And, they want to mobilize it. But in general, we don't know what we're doing with blackheads in my mind. I mean, walnuts are amazing. They're both asperites. Walnuts breed so easily. They almost think they're bluebirds, They're second to children's pythons in terms of being willing to breed them. They're not, for us, they're not good because they're freak out, they move their eggs all the time and stuff like that. Yeah. But blackheads people produce them. But they'll produce them and they'll have these weird babies, or the babies don't do that good, or they, I produce them, but I have 5 females, 1 produced. It's like, is that success? I mean, it's not complete.
You're describing my life.
Yeah, it's like to a T. Yeah,
mixed to children's pythons, you'll get 95%. But again, you can screw that up too. I bet you can figure out a way to screw them up too. And I know people that do. Like I have ways that I overwinter them and all that. And I'm not saying it's the way you have to do, but it's a way that I've used for 20 years and it works every time.
Why change it? Yeah.
And I've shared it, and I know people have applied it to other pythons. People, big python breeders say, "Now, I said, it's only for children's pythons that we really do this." And it's basically not keeping them continually at low temperature. It's giving them 6 hours a day of not hot, but increased temperature and the subsurface heating where they can thermoregulate. And then they definitely cycle just fine from that. They get the stimulation, but they just come out more hydrated, more active, more alert, quicker. The starting of reproduction seems to go well, quicker onset than when you just keep them cool. I mean, cool, like for children's python, 15 degrees Celsius, so 59.
Right. Gotcha.
But then I just bump them up for 6 hours a day up to 20, which is 68. It's still cool, but with subsurface heating for 6 hours, which they will throw, and they sit on that and they love that heat. Yeah. We also don't see as many bad sheds. It's just, it really works well. And like I said, I've used it almost exclusively with children's pythons, but like I said, I had a friend who has a lot of different pythons and started implementing it and seeing improvement on some of the Morelia, like diamonds and jungles.
Right.
So,
yeah.
I love that answer.
Ways, but
blackheads, a mess.
Blackheads that makes them. That's what makes them tempting, right? You fall in that trap.
No, I think you're right on. Yeah,
to me, it's interesting because the fail points are so many places, and none of them are like they're more hurdles. They're not like absolute walls that you stop there. You get past that one or this one, or you get I got this female through, but. Actually, you don't have it really figured out until the majority of the snakes are breeding, right, and producing good, high quality offspring. And I don't mean high quality what you guys mean pretty and all that. I don't care what they look like.
Yeah, viable.
I want alert, active, bitey,
might survive.
That's why I can keep children's pythons, and mine aren't the prettiest, but they're great in all those other categories which I care about. But it's good to have the pretty thing, but if the pretty thing is
really messed up,
not going to feed and you're force feeding. You may be able to get it through things, but you still don't have it right because in nature they're not poor feeders. Now you do have an animal that's here you're not lizard eaters. So getting it to eat pinkies and a lot of these things are tricky. You're trying to feed it something it doesn't normally eat. A lot of times because you got to look at do you have babies that just are in a condition where they're just not going to feed because they're not in good health, or the babies that want to feed and everything. They're just what you're offering them is not food according to them. They're not saying I'm not eating that because they're just I don't recognize that. And you can like green trees, you can get some that's another one. If you incubate them just right, they'll just take mice right away. Baby pinkies. If you don't, you got to get to that lizard or frog, and then they'll eat those. And then you get some that don't want to eat. And so there is it's not success or fail. There's this whole continuum of where you're at. And the blackheads have all these steps. You can get past them all, and then you think you had it figured out, or you get this one female that breeds every year, but the other 4 females you have in identical cages, one breeds every 3rd year and the other ones don't breed, something like that. It's like, why is she doing this? But it's interesting. It's not good for me because I need numbers. Good for you guys to take on that challenge and be.
He's the only one. I don't want to mess with blackheads. Yeah, I don't have I would get too easily frustrated. Yeah, no.
Well, I think that's why Todd and I get along so well, is we just love the Asphidites. For better or for worse.
You can all share your sob stories.
That's right.
Misery loves company.
Oh yeah, of course.
I am interested. You've referenced a few times perfect incubation, and how that leads to better outcomes in the babies. Could you describe for us what perfect incubation looks like to you?
Okay, I'm glad that last point is to me because to eat, there are many ways to do something right, and we figured out for my environment for what it is. I don't even know we have 2 scoops that we use. I don't remember the balance. We publish in all our papers, but again, that's why I have papers so I can look it up. But instead of like people say, 1-to-1 by weight. It's like, who wants to weigh the vermiculite and weigh it? But if I tell my students, you get this scoop full of dry perlite and this scoop, and then fill water this high, and I forgot it's 25 mils of water with 96 grams of. Basically, I love perlite. I'm a big believer in it over things like vermiculite. Like you get eggs that get covered in little dirt and dust, and the more that stuff stick on, the less oxygen transfer you're going to get, right? And so perlite doesn't stick to the eggs. The water goes inside the perlite, so it's not. If you make it real wet, if you can squeeze it and you get water out, it's way too wet. Just damp and you do that, the eggs are really touching the dry part of the perlite, and the water's kind of trapped inside. And that's what perlite was made for, right? You put it in potting soil to help retain water. It's like it's like a sponge, but it holds that water better. And so, and there are different ways. The best way, I don't necessarily do it, but I think the best way is you do it in a big enough container that you have that moisture that you incubate eggs, you never have to add a drop of water because there's so much moisture. I mean, some people, I've known people that, use trash cans, whole trash cans with glass on top for one clutch per clutch of eggs. And you got this whole room. If you have the space, great. But you don't have to do anything because there's so much, the proportion of water to your substrate is the same as I use, but you're going to lose every time you open it, you lose water. The egg's going to take up some water. If it's in a small little container, that can be a fair amount of the water, and your substrate's going to dry out. If you're in this giant trash can or a big, whatever tub. And again, so I do feel that if you have the space and something's really valuable, get in a bigger tub, get that mix, and don't, for you, early on I used to just guess it, but now it's like figure out what works and just, like I said, you don't have to weigh it, just get scoops and we'll fill that water up, fill this with, mix it, stir it, and you're good. And I usually we mix it in a lot of times in large volumes, but, and then, like I said, the volume is important. We've gotten to the point we used to have a lot of little holes in the sides. I tend to avoid that and just check them early on, check them twice a week by opening the lid, check it, close it. Tends to not desiccate. Otherwise, you put the holes in. But you can do it. I mean, I've done it successfully with holes. It's just, again, when you're dealing with 40 clutches or something, you just don't want to be.
Everything in autopilot.
And occasionally, and you want to if they are I think if they're starting to cave in early, you got to deal with it. You can't just see if it'll make it through. If it's late in the incubation, that's good news. They're about to hatch, right? But early on, and you don't want to go in there and mist them with a spray bottle. You'll kill those eggs. You get water on them. So for me, it's dripping. Just 1 or 2 cc's down the side of the wall of it. You can do that, and if it's you have time. If you catch it early and start acting early, you can actually start doing this. Each day you don't have to say, it's going to need 20 mils. Oh shit! Now I made soup.
Yeah.
But this is where I'm getting into more of the hobbyist approach. These are all my anecdotal opinions that we haven't studied. All the other stuff. I want to point the difference. The other stuff is all facts and organized and controlled.
Absolutely.
A lot of this is just for this one species, and literally hundreds and hundreds of clutches.
Gotcha.
Over 1,000 clutches with these guys.
What's the temp that you would program your incubator to?
It kind of varies. Usually it's in the 31, 32 C.
Okay.
88 to 90 somewhere there.
Yeah.
It's just so much nicer.
It's clean.
Yeah. Exactly. But yeah, I mean, I think a lot of people have the temperature side thing pretty good. And I'm not a fan of adjusting it, because I think people go, oh, but a lot of places the air temperature doesn't change much. Like I told you when I was in Cape York. Mm-hmm. But even if the air temperature, if this animal's underground in a burrow wrapped around it, air temperature can be changing like crazy. But even down here, we don't, we get 120 by the day, and it can get 85 at night. That's a 35 change. Underground, more than a foot. See, I used
thank you.
I went from metric there. The temperature's constant pretty much all day. And so you don't have to go far to, it's like people when they, especially animals that they go in deep hibernation, or even pythons. Oh, and I just had this with someone with children's pythons. Oh, I took them out of hibernation. I just warmed them up slowly, a couple of degrees a day at a time. And all of a sudden he had all these respiratory problems. In the wild, the animal's underground. If they're overwintering or whatever, they're underground. And then one day they decide to come up. And when they come up, they're coming up and they're getting themselves to preferred body temperature, at least for a few hours a day, maybe not long, but they're getting a preferred body temperature every day. When you put them at this intermediate temperature, it's temperature where their immune system sucks, but now bacteria can replicate much quicker. Mm-hmm. And so you're setting them up for failure. And it's like, and it's not even people, it's natural to, I follow the calendar adjust. It's like, these animals are going underground and they're coming up to bask. If you see an animal that in spring when it emerges, it goes and basks.
Right.
And it's going to heat itself up. And like I said, they're not able to do it all day. They're limited in the duration they can do it. But if you put transmitters in these guys and you measure body temperature, button temperature loggers in them, you'll see they go in, they come up, they hit a temp, they stay at the temperature even for a few hours, and then they come down and they go down quickly. There's not a lot of, I'm sitting in this for a week, I'm at this intermediate temperature.
In the middle zone, yeah.
Yeah, they don't ramp.
Those intermediate, they don't ramp. And,
right.
And this is true. We've measured this in rattlesnakes. We've measured this in Gila monsters and vipers in Europe. And they all do this. They come up and it's about then, as the days get warmer, they increase the duration that they're at that optimal temperature.
Right.
It's still the same pattern, just they can do it longer. And same thing with pregnant females versus non-pregnant. Pregnant females tend to raise their body temperature about 1.5 degrees over a non-pregnant female. But they also, if you give them a thermal gradient, they'll choose the work to stay at that temperature longer part of the day. So it's not just they're 1.5 degrees warmer. They're 1.5 degrees warmer at any one moment, but they're not doing it just for 4 or 5 hours like non-reproductive. They're doing it for 7 or 8 hours. Mm-hmm. So it's additive. It's like they're getting more heat, not only that 1.5 degrees when they're both at peak, but the non-reproductive female will go down or go out, not try and maintain optimal temperature for as long. And again, we've seen this in a lot of temperatures. So you got to look at, and plus pregnant females are more careful regulators. The variance, the variation that the temperature gets over the day is much less in a female that's reproductive, pregnant female or gravid female than we see in non-reproductives. So they're doing a lot to regulate temperature.
Okay.
Is that what you were talking about when you were talking about the embryos developing in the female at the beginning? Is that temperature really the thing that you want to pay attention to?
Oh, and these females are they raise their temperature. Like I said, we've published multiple papers about they're raising their body temperature. We've looked at whether they're dehydrated, do they not raise it, and they still raise the temperature so much, the same amount, because it's critical. If they digestion, they also raise their body. They'll bask more and raise their body temperature. Mm-hmm. But if you make them dehydrated, they reduce the amount they do it. But for reproduction, they're going to go all the way up. And if you look at these children, a lot of pythons, you've seen a lot of pictures people have published, but they roll over. They're like rotisserie chickens, right? They're like this, and whether they're getting heated from below or above, they're heating up their belly. But it's like, okay, but what about the other side of the eggs, or eggs that are not all perfectly in line, and they'll roll on the belly. And I mean, I get students like, freak out, the snake's dead, or down. And we've even published the frequency at which they're upside down. Now, when they're non-reproductive, occasionally they'll do that, but it's like 10% of the time that they do it compared to reproductive. And what they're doing, it's the same reason that you rotisserie chicken, why it's better that way than if you just put it in and let it bake, right? Because you're evenly cooking this thing, and they're doing that. They're adjusting that So they're really careful controlling the temperature and monitoring it. And that's why I said, if you give that female, the one thing kind of like if you get, I do a lights out, I turn off the heat, supplemental heat at night because in the wild they don't get supplemental heat. That's a good way to get bad eggs. Because in the wild they're not getting the air temperature. Now there are some pythons, berms and diamonds that will be on the surface or among the leaf litter. It's like they're on the surface, but they're buried in leaves. Mm-hmm. Or in Florida, it doesn't matter. It's warm day and night. It's humid day, So you got to think about not what's the temperature. You can't look at an atlas or meteorological data and say, what's the high and low of where they come from?
Mm-hmm. Right.
It's got to be what the snake is doing. And you got to know what they're doing. Are they nesting? Are they brooding underground? Are they brooding on the surface? And then before you go and decide, I'm going to do it more naturally and mimic this thing, And I think a lot of people want to do things naturally, and that's why they eat eggs with the females and all this stuff. But I'm more about
put snow on
knowing what's happening naturally, and then me being able to duplicate it and kind of make sure that I can regulate that and carefully do it instead of assume the female's going to. Because you cannot keep your cage at a steady humidity like you can an incubator.
Right.
You can keep that incubator rock solid humidity wise, or you can adjust it if you get a fancy one, whatever. But the cage, it's not going to be as humid, right? And then you're relying on her and her behavior of brooding and all that. When, I get it, but
if she's doing the best job that she can do, she might be causing those hypoxic conditions that you.
She's causing those hypoxic conditions. I'm more worried about desiccation in these, these cages. No matter how humid, it can be dry or you get it wet. It gets too wet in there. Whereas again, I can measure out volume of things, mix it together, and that's it. Versus, if you're going to got bedding in a cage, you're not going to put one barrel of bedding and 1 gallon of water in there and mix it evenly, and then it's going to desiccate. It's going to dry out more because it's not sealed very well, even if it is pretty like a vision cage, which is mostly closed. But
so it's like water retention in the egg over heat, because there was one year where my scrambled brain put a clutch of eggs in my incubator, having forgotten that I had unplugged it because I thought I was done for the year. And this clutch of because this clutch of carpet pythons hatched, but it took an extra month than the normal thing. And, obviously everybody's like, well, temperature needs to be this. Well, it was in the 80s, but it wasn't high 80s. I think it was like 82, maybe 80 to 82. And they still hatched all perfectly fine. Babies that maybe were a little reluctant to eat, but still. Yeah,
that's what I was just going to say. It's success, failure, but also the quality is a continuum.
Yeah, quality would suck.
Hatch or no hatch. But no, I agree. I mean, temperature, they can tolerate pretty considerable temperature changes, and we've even shown like gravity of different things that it's about getting to that optimal temperature for a certain minimum amount of hours, and then at night they can, for different things. It just varies depending on where the animals are. That was like with aspic vipers, where they live, it gets cold at night, but that's not what the pythons are doing. So you want to pay attention to the natural environments, but I think water and temperature, I wouldn't say one's more important. I think it's just temperature is so much easier to control. You get a darn thermostat, proportional heater, and you're done. Unless you unplug it.
Unless you unplug the thing,
I can't imagine anybody would unplug their incubator when they have snakes in it, but we've all been there. I've been
power outages. If you're in California, it's out of your hands.
But the water is a harder thing to balance, and we do know that these eggs are extremely sensitive to they're more sensitive to being wet than they are desiccated. Well, they're going to die desiccated, but it's just going to take longer. Being wet, it can only take, like a lot of things, like I know people, and we do it sometimes, just tilt the cages. So if you do get condensation, or when you start doing that, it sort of goes aside and dries on the side, and the eggs are in the middle, so they're not being dripped on. Because I swear I've seen where like an egg's dropped and then it starts rotting right where that drop hit.
Is the mechanism of death
sensitive to water?
Is the mechanism of death in that case suffocation?
I don't know, and that's It seems like they're prone to fungal infection, because you'll get those and the egg will start rotting. You open it up, the baby's still alive. It won't be for long, but so I think you're interfering with, you're allowing a fungal or even possibly a bacterial infection on these eggs. But again, why is a python egg more susceptible than a colubrid egg on these things? And I don't get it. But again, I haven't done and take eggs, and how much water can I put on a different amount?
See how many drops till you die. Yeah.
Eggs, not only die, it's the quality of the offspring. All these quality tests. Again, it's not the big question, but I share those same kind of curiosities, and you start thinking, and at that point I kind of become like a hobbyist. I get ideas, and I try, and when I talk to guys like you, I try and make sure you guys understand when it's stuff that we've proven or with data collection and designed experiments versus just years of experience. And years of experience is important for everybody, and mine's very focused. I mean, like I said, I've done the heat production of a wide variety of pythons, but I haven't had all those species, whereas children's I've had for 25 years. And so we've done a lot of different things. We've done a lot of things to intentionally not do that. Our goal is not to produce as many babies as possible. So we do things to look at whether it affects quality and things like that. And we see ones that didn't affect quality, or something that did, or so it helps us become informed without worrying about losing eggs. Mm-hmm. Right. How many baby children's pythons do I need?
I'm curious with, I would assume that this is a temperature thing, but you'll see ball pythons wrap their water ball at the beginning of like a breeding season. Is that, you think that she's trying to, do you have any thoughts on what's going on there? Is it?
I know what you're talking about. I don't, and is there a temperature thing? Is it just they're starting to get in this desire to coil? We did publish a paper saying when you get a female children's python, coil her on her eggs, you can take her off and you can give her eggs of a different female. Coils on just like they were hers. You can suck the yolk out of all the eggs and then inject like a plaster of Paris, a dilute in there to make them solid. So they look like eggs, but there's no yolk or anything in them anymore, embryos. Yeah. And she'll coil on them like they're her own. So it's just the one thing we gave, and exactly the same amount, fully dedicated to it. We've got a bunch of river rocks, similar shape to children's pythons, and epoxied them together and gave her pop. Now, she didn't do it as much, but still 50% of the time that she normally coiled the other one, she was still on these eggs. They're so driven to coil on, what they know they recently laid. They know they're going to coil. So it's, and you think about it, they lay eggs. They're not in a big rookery of all these different eggs. I got to recognize my eggs. I know I laid them in this hole. As soon as I find anything that resembles eggs, I'm going to coil on it because those are my eggs. What else could they be? No one else has epoxied rocks together and pull eggs from a different female and put them in there. Right?
They're really messed up.
Yeah, why would
we think of very evil things to do.
I'm just kidding. I love it.
But but there is this they're totally driven, and I'm sure it's hormonally driven, probably progesterone or could be any of the thyroid hormones that are just driving this innate behavior, which makes sense because, like we think about a lot of bird colonies, whether in trees or on the ground, there's just so many. You got to know your nest. You want to know your offspring versus, and even with birds, they've shown that birds that breed in groups and flocks and rookeries have very good offspring identification or egg identification. Like, emperor penguin can find its little egg, right?
This is my kid.
But birds that breed solitary don't have those. They don't detect eggs, and that's where cuckoos lay an egg in another bird's nest. The egg could be twice the size of the other eggs, different color, and the female will hatch it. It'll hatch bigger and look weirder than the other ones, and it grows faster, and she feeds it, and then it kicks the other babies out, and this other female raises it because she is just not making judgment. Because I know I have my nest in this tree, and if I fly back to that tree, any nest is mine, any egg in my nest is mine.
Right.
Cuckoos evolved the thing of like, well, I don't want to raise eggs. I want one egg. A bunch of different nests that I find. And so, so we see it, and it's really cool, like within birds, because it's a single group. But if there's a greater risk of misjudging what offspring are yours, then you're going to they need the ability to identify your eggs and whether they're good versus these, we haven't tried. The one thing they do seem to notice, but we didn't do it in that study, it's not part of the published, is using rotting eggs. Because a lot of pythons will nose out bad eggs, especially when they first lay them. You see them all around the clutch, and there'll be a couple bad eggs scattered around, either duds or early on they start going bad if they're not stuck to the clutch. They'll kick them out. So I think they recognize that. But that's a different selective pressure. It's not like this is my egg or not my egg. This is bad for my clutch. So I'm kicking it out. So It's interesting, but it makes sense. It's not, oh, they're so stupid, they're coiling on rocks. Right. It's like, no, we're just mean.
Yeah.
I took advantage of their natural history that they lay eggs isolated in a spot that they don't need to. Because, water pythons are known to abandon their eggs, go out and bask, heat up, and then bring heat back. They don't produce, they don't shiver, but they can bring heat to the eggs by basking and going back on the eggs. And so you do need to find your eggs. But I know I laid them down this hole. There's two never laying the same thing. They don't need to distinguish what's theirs. And so you give them something that is at all similar to their eggs. They're going to assume it's their eggs.
So back to the third of the time inside of mom, that period that is very important that most of us hobbyists don't think about because we don't see marshmallow-shaped things yet on the ground.
You eat weird marshmallows.
Yeah.
Fair. It sounds like the water limitation. So that can be one way to screw it up if she can't get water. However, I think you do have some research that we've
done a lot of research that, if you limit her water, the eggs come out a little smaller, lighter weight, and a little higher humidity. But overall, the eggs are more protected. She more takes it on, and she'll actually increase. So if you burn your fat, there's very little water in fat. Right. So if you burn it, you don't produce there's not a lot of water freed from it. If you burn protein's moist. Think about it. Beef jerky, why is it so expensive? Because you're buying a big steak, but you're eating a little strip of meat because you dehydrate. Right. You took away 70% of the weight that they sell per pound the steak. Now they've got to quadruple the price of the jerky because you're not buying that 70% water anymore. You're buying just the protein. So it's not even just breaking down the proteins and metabolizing proteins producing water, but just the water that's bound in muscle that makes muscle different than just isolated proteins. There's water part of that. And so when they're dehydrated, they burn mostly fats, but they burn some proteins to produce their eggs, which makes sense. You need eggs have lipoproteins. You got to have some protein to deliver it. But if they're dehydrated, they'll shift to burn a lot more protein than they do if they're hydrated. And we think that is to produce that water, to release some water because they don't drink water. There's no water to drink. Where can I get water from? Hey, my tissues have water. And we know that affects their apaxial muscles down their back, right on the side of their spine. They get smaller. They metabolize them more for producing that clutch. Right. And that compromises, we don't do it all the time, but we did initially shown that smaller apaxial muscles mean smaller constriction strength and strike strength. So they're doing it at a cost to them, but they're going, I have a better chance of feeding and building up my muscle than if I lay a desiccated egg. Right. We'll let the egg be a little dehydrated, but not desiccated, because otherwise I'm going to get nothing. And that, for a female snake, that can be 3 to 4 years of investment, right? In energy. So they can do everything they can to say that. So they can mobilize water from other sources. There's a limitation, but they do a pretty good job of it. I think in the female, it's more about temperature, because you don't have to worry about the egg desiccating inside the female. You can worry about it being a little high osmolality, but I think a lot of it's temperature, not giving that. Yeah, it's an environment where they're cool enough, or you get them too hot. Heat is bad too, and you get these cages. You want to make a cage with very little circulation to keep it nice and humid, but then
airflow.
Yeah, I only have the heat on one side. Well, the heat it's going to spread, right? Unless you have some airflow in there, and so you've got to have that ability of these females. They're not always, they sit on the heat most of the time, but they come off of it,
right?
They move, and if you have a female and if you have a gravid python. And it's like, she spends all the time on the heat. You're screwing up. She's sitting on the heat because she wants more heat. You're not giving her enough heat. If she's always on the cold end, the quick pushed against the side, you're screwing. Like I always tell people, listen to your snakes. And it's like, people go, huh? That doesn't work. But, look at them. If they're always, she loves it. She's always on the heat nonstop. So she's doing a good job. She's grabbing. It's like, she's doing a good job, but you're not. Because she's trying to get she's in the hottest place. If she's in the hottest place, that means she's in need of heat. And so you want that animal that, spends some time in there, but mostly spends about, in my way, I like looking about a third of the way from the heat to the end in there, because if they want to warm up, they can move to the heat. If they want to cool down, they can move away, and they have that choice. Whereas if they're at one end or the other, to me, that suggests they want to go further.
Right.
It could be coincidence that, they're at that perfect temperature at the hottest spot. But I'd rather the hottest spot be hotter than what she wants, and she'll let you know. She'll be just off of it, and you can really look at where they're coiling, and if they're not, you are jeopardizing the quality of that egg that's going to come out.
During that that time as well, could stress, corticosterone levels impact how healthy the embryos and eggs are when they're laid? Like when mom has eggs in them, people will be palpating the females, trying to figure out how far along she is, ultrasounding her. Can that be deleterious as well?
There's nothing wrong with ultrasound. We do it all the time. No, but no, we limit it. I can do it every day. It's like, no.
Please don't do that.
2 weeks is fine. Once every 2 weeks. I think there's some, but again, corticosterone is a stress hormone, but it's an energy mobilization hormone. And just before laying eggs or giving birth, if they're pregnant snakes, you'll see a rise in corticosterone to support that process. It's human babies. You get an increase in corticosterone prior to birth. So some increase is not harmful. It's an energy mobilizing. Females during vitellogenesis tend to have elevated steroids. But I think if you palpated recently and you palpated a number of eggs, there's no reason to palpate it again. She's cycling, you have eggs. And that's why I like ultrasound. Ultrasound, you can just pull them, you can put them down, you put the transducer against their side, and you can pick up, you can monitor, because we want to monitor size of eggs, the rate of development, and calculate, but you just grab them, put them down, cabinet versus, and I don't like doing it on their belly. I like let them sit flat, and then you just do it on their side. It's a lot less, disturbance. I don't want to say it's stressful now because we don't know how tolerant, because something that's stressful to Lucas may be something that Eric looks at and goes, I don't care.
Yeah,
probably
been exposed to it. It's a lot of things. Think about people with snakes. People get really stressed out about snakes. A couple of you guys have cages right next to you, right? You're not stressed out. You get used to it. So, to what extent pythons or any animal, is stressed also depends on how well they're acclimated. If you have snakes that it's really your pet and you're handling it every day and then you breed them, I guess you can handle them almost every day and they're not going to care. If you have these snakes like most of us do, when you breed, you don't touch them much. Then all of a sudden you start handling them a lot. Yeah, there's probably some, it's not good for them, but I wouldn't say never take them out of there. Never, it's bad to ultrasound. Ultrasound's good because, especially when you have a lot of animals, you want to know which ones are going to be more likely to be laying soon, or which ones should have laid, or we look at, ovulation, when they're going to ovulate, because we time our treatments not days, but when follicles get a certain size, then we'll start taking their water away or give them something or whatever, and look at the impacts of that. And then we can also do it during breeding. Once they ovulate, we don't ultrasound them anymore. There's no reason to. The eggs, you can see shell development, all that, but you're going to see it when it comes out. If you're doing it just to solve your curiosity, but if it's actionable, if doing it's going to lead to you needing to do something, because, when they get to the stage, I want to move them, or, for us, we need to treat them, then, there's no issue with it. But never do things that are just for curiosity. Just be patient, But if it's,
and be careful with scissors.
But I want to know because it's going to influence what I'm doing. If I want to, and again, whether the female needs more heat or not or whatever. She's pregnant. I want to give her more heat. It's like, you don't need to pick her. I mean, look at it. Like I said, if she's on the heat all the time, she needs more heat. If she's not, she doesn't.
Right.
Touch the animal to know if you need to give her more heat or not. They will let you know very well, because
awesome.
They're going to choose it. So
I did want to talk. I've referenced this paper a couple times, and since you're here, I figured
one of mine.
Yes,
yeah,
it was the one you did with Python Curtis, and it had to do with
my first Python paper.
Yes, with the effects of the male presence in reproductive activity. Can you talk to us a little bit about that?
Yeah, that's kind of fascinating, because there's been a lot of evidence in garter snakes, the Manitoba garter snakes, that the female cycling is heavily influenced by mating by the males, and that mating is what stimulates. Sort of like when you think about cats or ferrets, they don't ovulate; they're induced ovulation. I mean, they need a male to stimulate them. And like if you have a cat that's in lordosis, always screaming, a female cat that's mature, she's intact, they scream all the time. You can either mate her, or you can just take a glass rod and imitate insemination, and then she'll say, "Okay, I'll ovulate now," and you get past it. So we see it in a lot of species, but so these garter snakes tend to hold off follicle development until they breed, and they have the short-term sperm storage, which basically all snakes. Most snakes are breeding somewhere during early or mid vitellogenesis. They don't breed after ovulation or right at ovulation. Females have those. If you're breeding them right at ovulation, you're losing out on a lot of opportunity. But what we found with these Python curtis, I don't even know which one they are now because they blew those up too.
I don't know.
But
whatever.
If they females that didn't have males would start, all of them would start early follicular growth where the follicle gets growth, but it's mostly water. If you ultrasound it, looks black, and you just don't start getting much yolk. And they'll all do that, and they'll start putting a little bit of yolk, start getting a little cloudy. But if there's no male around, they just regress those. If there's the male present with them, they'll go and ovulate. It produces and that doesn't, and it's not absolute, for the study was, but I mean, a lot of people know that, that I've had a female, I mean, especially some clues like corn snakes, like chickens, they'll throw eggs if they never see a male, infertile eggs a lot, oftentimes, but they'll cycle anyhow. And you'll get in with the pythons, a female that, throws a clutch and she, I didn't want to breed her this year. And I've had it with children's pythons, female that we didn't introduce to a male, because we want non-reproductive group as one of our groups. And all of a sudden they lay a bunch of, bad eggs. So it's not absolute, but it seems to be heavily driven. And you think about the selective advantage. Why put all this energy into follicles if a male's not going to find you? And odds are pretty good a male will find you. But if you know that male's there, you want to time it with that presence of the male. And yes, as long as they haven't ovulated, they can reabsorb that yolk in those follicles. But there's energy involved in putting the yolk into the follicle. There's energy involved in taking it back out. And so why waste that unless you have this male presence? So, it's an interesting little study that we did on the side. It wasn't part of my dissertation or everything. Is an opportunity we had with these snakes. And it was pretty exciting because previously, problem with all these Manitoba garter snakes, cool thing is they did tons of them because they get thousands of them. They're there, but all of a sudden you're saying snakes do this. And snakes at very high latitude that have a den of 1,000, 2,000 snakes do that, but it's not normal for other snakes. So it was interesting to show what happens in these Manitoba high altitude or high latitude snakes. We also see in the tropical snake, that also we see this thing, and whether it's across the board in snakes and to what, I mean, we also have seen parthenogenesis, right? In snakes, there's no male, female has never seen a male produces babies that are just clones of herself. Now, they don't do that often. Most of the time, they're not going to, they don't breed. A lot of females that see males don't breed. But, that we'll never know what drives a female to trigger whether they're going to produce sexually or asexually, because you would need thousands of females taking all your samples constantly in hopes that a handful will actually throw out a clutch, right, and see if they're fertile, and you do the genetics to see the clones. But, this facultative parthenogenesis was thought to be, it doesn't exist. And it was Burmese do this is the big thing. And then there's even a paper that shows that with both cottonmouths and copperheads, I think with 20-something females from the wild, pregnant females that they brought in, each of them had one or two of those clutches ended up being parthenogenic. So it occurs in the wild too. So it's you don't, and clearly if you're going to produce parthenogenically, you don't have to wait for male stimulation. And we called it male presence because we didn't know for sure whether they copulated or they were just there. I assumed it was copulation, but we didn't know. We didn't have that. It just said male presence. So, but I do think it does help to stimulate that process, the onset of the reproductive cycle for the female, and it makes sense. There's that just to do that. Because you're not like a mammal, like a human, where you're putting out this little tiny ova with a handful of support cells once a month. Who cares? It's a bigger deal for women is menstrual cycle, right? All that tissue, all that blood that they're losing is enormous. But why did that evolve? Is because it evolved in a situation where females rarely ever ovulated and didn't become pregnant. Because they're in groups and they only got pregnant. If they didn't have enough energy reserves, then they don't ovulate. But if they ovulate, there's going to be a male there. But if it doesn't happen, you need a way to recycle things. But yeah, for a mammal, a mouse, whatever, it doesn't have like a menstrual, to throw out this small number of cells, it's not a big deal. But if you're a snake with all that yolk, all the energy that's needed to produce a baby is all there. If you ovulate that and you lose that energy, that's a waste of a lot of energy that took you years to accumulate.
Yeah, totally.
It's the same reason why females take years to, they're capital breeders, right? They need to collect stores before they ovulate, before they decide to reproduce, because they can't assume, I'll find food this week, because snakes may not have food for months. Whereas if you're a little mouse, as long as there's a lot of grass around and seeds, I know I have plenty of food. I don't need a lot of energy stores to make it through reproduction. But a snake accumulates all the stores, all the energy it needs for that entire reproduction. before it will actually start a cycle, because it doesn't know if it'll get a meal. And oftentimes they're so busy thermoregulating and doing that they're not actually foraging. So the odds of seeing a meal isn't likely, even if you offer a female meal and she'll take it. If in the wild she's not foraging, not finding a rodent trail to ambush, that, she's not, even if she's willing, she's not going to find one when she's just coiled on a warm spot or someplace where she knows is great for the development, but isn't necessarily feeding.
So do you guys increase the food of your children's pythons coming into the season to kind of get your buck?
The way we do, again, this is just hobbyist here.
Yeah.
The way I do it is when they lay, and I can, most of them breed every year.
Right.
As soon as they lay, we just pound them with food. Once coach,
got it.
About
just
3 months,
we
get them to the weight that they were previously. We don't want to get them overly fat. Then we stop and feed them about once a month for the rest of until we put them down. And we usually put them down in first week of December, wake them up first week of February. So, and by then, so that we get that energy into them early. We won't want to spread out. And we don't. And then because as soon as they emerge, they start breeding within a couple of weeks. They're not like some pythons that will breed while they're hibernating. And children's pythons can do it sometimes, but again, because we can control it, and I've developed the incubation or an overwintering that avoids females starting a cycle until we pull them out. But it does put them in a good condition, hydration state, that they come out in good shape. They don't have to get,
the bulk up,
or anything, food or water. They come out in good shape.
Okay, Eric, do you want to go?
You want me to say it? Okay.
No, I can
coward.
say it.
You coward.
I'll do it. So one of the other common practices in the hobby that I'm sure you are aware of is some people will call it manual pipping. Others will say cutting the eggs. And of course, distinction between the people that are literally sawing the egg in half to see what colors they got and the small slit to allow for exit. Yeah. In terms of the physiology of the egg, is there really any reason to do that? Is it harmful every time? Some people say they're worried that the baby won't have an egg tooth and might drown the egg. Yeah. If the egg tooth breaks off, of course,
because
I know
it bumps into what's it going to bump into?
Certainly. And perhaps the first thought there is that one wasn't supposed to hatch anyway. But what are your thoughts on that?
I mean, I'm not I know some people like, it's this day, one slit, I'm going to go slit them all. And, I think snake knows, And again, if they're alive and they can't get out, then it's that quality. It's not hatching, not hatching. It's what quality. And so, if you're real careful and care, you can rescue a lot of these, lesser than optimal quality snakes and produce a good adult snake from it, But, so I don't do it. With the children's python, I don't do it at all. Like I have done it with chondro python because I've always had problems producing really good quality snake, consistent. So slicing, but then it's only just enough to provide a little more oxygen delay. I don't know what I'm doing really to do it other than to see the colors. Like what color did I kill? Again, you got to be patient and the animal should slit, and you got to think about if a lot of your snakes are dying full term, you got to look at what are you doing wrong, right? What is different? And I would say you got to look at this metabolism. Do you have enough air circulation in your incubator? Or are they developing to the point where, all of a sudden they're ramping up metabolism? They were fine when metabolism's here, but now it's high that now they're suffocating and they're suffocating the egg. And sometimes you open up an egg that didn't slit and you'll find that it has it's folded in half and stuck to, it's odd development. Mm-hmm. Or you get one that's slit, but it sticks its head out but never comes out all the way. And you'll find that they're
it's all twisted
up inside and whatnot. Yeah. So, there's developmental issues that occur, but
during those,
I don't think it's a standard practice. I mean, if you have the last egg or two, but if you're going to do it, a small slit, because the times that I have slit eggs, most of the time they just slit it somewhere else and they come out through the other hole.
Yeah. They make their own. Yeah,
that's hurtful.
Yeah, I made you this wonderful path. You went that way. Yeah.
With what you were just saying about dead in term or late term in the egg, with that last 10 days or so when the oxygen requirement is so much higher, is it a matter of simply opening the box once a day to get a sufficient amount of oxygen to those eggs, or what really, how do you meet that requirement?
Well, it depends on how big your box is relative to the, if you have like, again, a big environment, there's plenty of air in there, right? But we definitely increase the frequency. I'll start looking at them, every day. And again, because I'm not worried about water loss at that time, they're already evaporating out, condensing everything out in that situation. But again, we're talking just experience type of stuff. But yeah, a lot of it, it's either some fatal development, right, where they're just kinked or their heads, they have no nose, they don't have a face, sometimes
top jaw,
but you get these perfect good looking things. But yeah, I suspect the majority of them is, dude, you got to really think of how did I provide for this late, because that's really the big difference at the end. If you have this animal, especially if it's all pigmented and everything, it's all done. And, we go, oh, it died because it couldn't slit. Well, right. It not slit because it was deprived of oxygen, could not slit for, temperatures, poor developmental temperatures in mom even, but it's now just being, but when it's in mom, it lives while it's in the egg. It doesn't have to do anything, right? You don't have to be really good at anything if you're just sitting in a water world. We were in the amniotic sac. It's pretty easy to survive through that, but then, after slit and survive,
the outside world,
and make the adjustments to switch from, getting your oxygen from your blood vessels that are on the underside of the shell to constricting those vessels and starting to actually use your lungs. A lot of that is driven by corticosterone, drives a lot of these changes, these late changes to switch over to, that's a crazy birth. It's kind of a crazy thing. You got to switch real quick to going from, and it's just the lungs aren't inflated, with anything. So that first breath is the hardest breath. You got to feel something that's completely sealed. Think about a balloon that closes all the way. When you got to blow it up, you got to blow a lot harder until it stretches, and then it's easy to blow, change it. So it is a lot. It's a big demand on them to hatch. And so if you have an animal that's where, you can say slitting help. A lot of times you slit still doesn't mean they're going to come out and do well. They still only die in the egg, even though you slit the egg, right? Because
even that has happened.
Happens a lot.
Yeah. I had my one clutch of blackheads, which I know we've established are all screwed up anyway, so probably not worth talking about, but one of them crawled out and died right in the egg, so right at the end.
Yeah, and it's again, it's the whole picture. A lot of times you see the failure at the end, but that may not be the time that you screwed up,
right?
Because it's easy to survive until you have to do something.
You get here.
Well, you have to live.
Yeah.
But yeah, we're still not. And like I said, we all have. And this is what's really cool to sit around and talk. People, it's better if I have a beer in my hand. But I didn't get the delivery. Yeah, I saw it happening.
Yeah, well, it's.
I'm sorry, I'm on campus. I can't drink.
Some of us are still in there.
Really? At ASU?
We're number one in innovation, so we decided drinking's not a good thing. But unless you're.
That must be why Santa Cruz is not number one in innovation.
If the president or vice president have little get-togethers, they can have alcohol there. So it's kind of a biased rules. But
that's messed up.
It's not too far to go to get a beer around here. Though.
Okay.
Well, speaking of ASU, what are some of the current projects that you're working on?
What research you're working on right now, if you can tell us?
Sorry.
Well, this year, the work we're doing with the children's pythons. In fact, a lot of my children's pythons I've sent to another institution that we're collaborating with. I had been, but we didn't have the time because a lot of our work is currently looking at using rattlesnakes to look at adaptability to changing environmental conditions. So it has us in the field a lot and stuff like that. But we're looking at immune function and how how reproduction affects immune performance and the response of the embryo to stimuli, immune challenges. Like instead of challenging them with bacteria and inject them with bacterial infection and make them sick, you can actually give them lipopolysaccharide, LPS, which is on the walls of all these gram-negative bacteria, these things that get reptiles, and you can just inject them with that. And they're not getting bacteria. It's not harmful, but it's like you getting poison oak, right? You have this immune response that you're causing the trouble. And so so we look at the effectiveness, the extent of their immune response and how different environmental conditions can influence immune response. So a lot of things we look at is how things like limited water environment, dehydration affects most commonly digestibility, reproduction, and immune function, because those are three really critical steps that we're doing. And we also, so that's the study being done with the children's pythons. I'm not an immunologist, but my colleagues are. And we also have a big group of Gila monsters. And so we've done some work on looking at how hydration state affects digestion. We've done it in children's pythons, and we're trying to see, I guess some undergrads doing their theses on looking at that effect. We've recently just finished a study looking at how they find water. How do they sense water? So we know they need to drink, but how do you find water? Do you wantonly aim until you find a puddle? Because if the rain happens, rain doesn't happen often. When it does, it hits sand and it soaks in the ground. So there aren't that many standing puddles for very long. Right. So, they have to have a way to how they sense it. And amazingly, there's only been a few studies ever that looked at how any animal. There's a paper on elephants, a paper on dart frogs that look at how they find water and selected. So we basically made these little T mazes and have. Hold on just a sec.
Yeah, no worries.
Hey, I'm in a meeting. I'll call you. I'm sorry. I'll tell you a little bit. All right, bye.
Uh-oh. Did we get in trouble?
No. Sorry, you guys are important. You guys, I can just click and leave. Yeah. Which is, wondering where the hell I was. But
sorry.
No worries. What were we even talking about? Now I'm just
water and
how to find water. You made a T maze.
Oh yeah. Just how Gila monsters find water. And interesting. So we gave them tried distilled water, which is H2O, and there's no volatile compounds that they give us, so they shouldn't be able to detect it, and they can't. We tried water from. We have a pond with. Pupfish in it. So we took water from a pond, which has all sorts of volatile, organic stuff in it. And then we used tap water. It's thinking that, it's the compounds in the pond water that they're going to smell and pick up. And we showed that the only thing that they really smell well in the test was the tap water. And this isn't published. We just finished this. And it's like, what the hell? And then we thought about it. We did this on captive Gila monsters that we've had for years, and what do they get every day? Is tap water. And so
they know the tap water.
We have this great, at some point, like students actually take it and look at, if you give right out of the egg, you give them just pond water and you give them just tap water, and then when you test them, do the pond water ones choose look for pond water, and the tap water ones look for tap water. Oh my
God, that's awesome.
It's like it blew us away. It's like, what are you idiots? You're not, this isn't what you're supposed to smell in these bottle organic compounds. And
what do you mean you want the tap water?
No,
you got them hooked on chlorine.
Yeah, I was the idiot. They're smelling what they've been drinking for years, and they pick up, and they do. I mean, they have a high preference for going after that. It's interesting. They'll go down the little T maze, they'll walk, and it's fun. And they lick to the right, and they're actually making a decision. It's not like they run in the first one they go down. They're kind of lumbering lizards, right? So they're just tongue flicking right at that intersection, and then they choose a direction. And if they're more dehydrated, they're not better at going to the right place versus the wrong place, because it's either an empty bowl or one of the water types. But they get there faster, so they're not more able to distinguish the water, but they're more.
But they hustle,
motivated to make the decision and get there quicker. So they get there much quicker, but their percent success rate is the same as the other one. So they're not jeopardizing it. So, and this is based on, and these are hydration states that we actually measure in Gila monsters in the wild. We know they get to it. We're not saying, let's see how far they can get. It's like, we know from blood samples that during the hot dry season, they get to anywhere between this we call moderate and then significantly or considerable dehydrated, which is before any clinical signs. You look at them, you wouldn't notice that they're dehydrated, but we've seen changes in immune function. We see changes in not in any digestive parameters, which is interesting, but except for lowering of their body temperature during digestion. So there are effects. They know their body knows it's dehydrated, and they make different adjustments. But in this case, they see. And the other thing is, the more dehydrated they are, we've also looked at salinity, because if you have a puddle that evaporates and then rains again and puddle evaporates, and you're just going to build up salts in there. Mm-hmm. And so you start with highly saline water, and you just offer them progressively water bowls of down to tap water. And usually about halfway down our progression is when a moderately dehydrated will start drinking. The severely dehydrated will start drinking really early. And it's like, are they able to process that highly saline water? Is just, again, making like the water pipe, making a bad choice.
Yeah.
Ruined it. Right. They did bad choice. Like some people that are on an island, they're desiccated, so they drink the ocean
salt water.
It's not good, but you made a bad choice. And so, but then overall they drink more water when they're dehydrated. So and these are like curious little questions that my students come up with, right? And I think can just explain it better, because we know they have to drink. Eating eggs in mammals that we published does not, either rattlesnakes or Gila monsters, they cannot maintain water balance that way. They need freestanding water to drink. And so it gave us the question of, how do they find this water? So when it comes available, it's available for a short amount of time. And they can't be just random looking. And you can say part of it's probably memory. They know their home range. They know where the feeding areas. But again, like an elephant uses memory, but they also use the smell of water to know which water hole is more likely direction to go in. So, I think these Gilas, they know general areas, but to be able to say, okay, I'm in the area, but I can smell water, just like they're licking to smell eggs or small bunnies or rodents, that they're actually picking up these water scents. But yeah, kind of, it's a weird thing. It's like, well, they smell tap water better than they go to things. But
that's great.
Spoiled little bastards.
They were smarter than me. They learned that that's what they drink, so they went to what they drink, and we didn't consider that awesome. Afterwards. Like,
I love experiments like that where you're like, we have everything considered, and then crap, we forgot this. So like, we didn't think about this. I love that kind of stuff.
And it's come so obvious. Like, and other times you get results you don't understand, and you just can't, and you just bash your head, can't figure out why is it different. Like, people it's always fun when your hypothesis is supported. But it's more fun when it's not, because when my hypothesis is supported, it's like, good, I know what I'm doing. But when it's not, it's like, wait, I've been doing this 20 years. How come I predicted this wrong? Why? What am I not thinking of? And so it gets you more thinking. It gets you developing new ideas, better than, to how you're going to go at it to really understand what's going on, because, you get this exposure, like, it's like experience with breeding. You learn things. We were talking about how we do eggs and all that, but my experience with research has also been decades, but sometimes I make the wrong prediction. And so the same thing can happen. So it's good to actually do the work and see what these guys are doing and try and understand how these animals live out there in a place that you'd be dead in, 36 hours.
Right.
They're living, breathing, and perfectly happy there.
Wow. That's
awesome.
So those aren't
this
Morelia.
Conversation.
They're just as cool.
I love Gila monsters.
I was talking about it for weeks.
But that just shows that we have a few study species we use a lot. We use rattlesnakes a lot because there are a lot of them out there. I'm not into venomous. People, you love venomous stuff. You do Gila monsters and rattlesnakes. Like, no. Gila monsters are fascinating because they feed on these nest contests. That's all they eat. They raid nests, and there aren't many nests out there.
Yeah. And
so it's fascinating to me. And then rattlesnakes, because there's a lot of them, and they spend a lot of time on the surface because they're ambush predators. So it's just logistics. And then we do the children's pythons are the three main species that we do most of our work on.
That's cool. That's awesome.
Yeah. This conversation has been awesome. Amazing.
Fantastic. I loved it.
Really good stuff.
So where are each of you guys at physically?
Lucas is in California.
Yeah, I know that.
I'm in Oakland.
Yeah. And Eric and I are in Pennsylvania outside of Philadelphia.
Okay.
Yeah.
Yep. We're East Coast kids.
Yeah.
So
I was born in New York City. So
there you go.
Oh, okay.
All right.
Well, there we go.
Yeah, I haven't been back in a long time, but
it didn't change that much. So, but we do end up popping around to the West. Like, I think right now one of our friends is on a mission to photograph all the different species of rattlesnake, and we keep tagging along with him to go to different parts and stuff like that to kind of find stuff. And
in Arizona alone, we have 19 if you count subspecies.
We did well in Arizona between you and me, Eric. Yeah.
You guys did do well. I got to edit some of that footage.
I think all total we're probably up to maybe 20 species so far.
What is it?
I know Rob is probably like 25.
25, you idiot. Yeah, I mean, I know that KJ sent me a picture today of they found an Eastern Diamondback on the place where we were looking for the one. And it looked 10 times better than the one that we found. And it's just like, well, yeah, a couple months later, and they were just emerging. So, of course, mine looked like crap, and yours is beautiful, full body, picturesque. It's like, oh, yeah, okay, fine, whatever. But yeah, you're headed out to.
Yeah, 25 is, you're getting close. You're making it hard now.
Oh, yeah, and that's going to get more interesting. Yeah, you got all the easy ones like Timbers out of the way. So, yeah.
Aatrox.
Yeah. And Aatrox.
Aatrox.
The other one. I've seen a lot of Aatrox.
It's a fascinating snake. When I had a 1 kilometer by half kilometer plot, 200 atrox on it.
What the hell?
Wow.
200 snakes. And atrox represented probably 95% of the snakes we found there. I mean, they're just so dominant. It's just amazing. And then they can be there and they have it's not like a very normal range. They occur all the way from Arkansas to Western California, Eastern California. It's just, it's a fascinating species.
That was the one thing that was actually out and about when we were in West Texas, and we went at the worst time. It was freezing cold and rainy, and there's an atrox. We're like, well, all right, at least they're still here. So we're doing something right. So it was. That's
the fun thing of doing research on them. You get to enjoy finding them because another atrox. It's like, yes, an atrox.
It's another one added to the file. Yeah, right. But this has been fantastic. We'll definitely want to try to do something with talking to you about this stuff later on because.
Well, if we wait long enough, we'll forget what we talk. I'll forget.
Exactly. We can do it. It's fine. I'm fine with that. We've had 13 years of shows. We can repeat. Yeah. Right. So
that's cool, guys. I'm glad. It sounds exciting. Sounds like you have fun doing it too.
Yeah, I mean, if we didn't, we would have stopped after at least, I think, 3 years. So I think somebody somewhere would have stopped us. But
go ahead, Owen.
Yeah,
sorry.
No, I'm saying, like, if there's anything, I don't know if there's stuff you want to throw out there. If there's places where students can contact you, if you don't want to hear from anybody or anything like that, that's fine too.
If you just Google my name, it's there. You'll get my phone, everything about
everything. He'll find you.
Are you looking for grad students or anything like that? Or are you looking for grad students, or is it not really?
Not really at the time because I'm moving toward retirement in a few years. And so I'm trying to finish up my PhDs and focus more on masters. I never had many master's students because the hardest year of a grad student is the first year where you got to turn them into something instead of a worthless piece of mass. Right. So, but for a master's student, you do that, it takes you a year, and then you get a year out of them before they leave. Whereas a PhD, you do it for a year and then you get, 4 more years out of them. And you can get to more exciting questions. You can push them a little harder to get into things that are maybe feasibility is not as obvious. You got to work on it more because you have more time. Mm-hmm. But now I don't want to be, I don't know.
Gotcha.
I'm not going to be 100% retired, but overseeing PhD. I have a lot of my PhD students now are shared. Mm-hmm. I have 2 that are in my lab, but then.
Well, I had to ask because I found my advisor through a podcast. So if you were, there might be some other little Lucas out there listening. Right now.
Trying to get his start somewhere. Yeah, that's
right.
It's always tricky. Cool. That's the hardest thing you do as a professor out of everything is find grad students and that work, because you're making, you talk to them a few times and then they come out and visit once and then you're making a 5-year commitment to each other. And
right. Yeah.
You got to make sure that the person's driven, but also there's a personality match. I mean, I'm very serious about my research and what I do, but you can also see I'm very sarcastic and I like having fun. And you can do both. Some people are really serious, or you can't be joking about everything. Though there's some things that, when it comes to what we do and our experiments, it's all seriousness. But let's have fun, just like you guys have fun doing these things, right? Yeah. You guys have fun doing it. Nobody's going to listen if you're bored.
Thank you.
We figured that out early on.
Oh, yeah, very quickly. Yeah, very quick. There's some rough shows in the first couple seasons. But, yeah. Oh, well, this is awesome.
Okay. Yeah.
I don't know, Eric, do we have any housekeeping or anything else that we need to do?
No.
Oh, cool. No. Freaking tastic. All right.
No, we do not.
Lucas, did you have anything you needed to add before we ended?
No. Thanks for letting me sit in.
Yeah, man.
I think I hope everyone enjoyed. Dale, I could listen to you for years.
Another hour, yeah.
I can talk for years. Especially if you start talking about, some of the stories.
It's amazing.
We can get into there.
Man,
we can do stories. We can have you back and do stories on research and other field herping and stuff, which I think would be a fun thing on that one. So
it's fantastic because you're a wealth of knowledge, but you're also just really fun to listen to. So thank you so much for being here and doing this.
We'll milk you for several episodes.
I was told by a colleague years ago that it's edutainment that we do.
Of course.
You can't educate without entertaining, because if the student's turned off, they're not going to learn anything. You can be very official. You can know everything, but you're not going to share it unless you can And a lot of times I'll just have, as you can see, I get sidetracked. I'll start telling a side story, and they're like,
but that's the best.
Where'd you go? You know, it's like, sometimes they have purpose. Other times it's like, I have no idea why I just said the story. But
I don't know how we got here,
I didn't show up waiting for the story. You know, they get through the whole lecture just looking for a story I'm going to tell about some stupid thing or want to badmouth somebody. You know. Now I have 3 people I can add to my bad mouthing list. So.
It's fine. It's what we do. All right. Well, that's it. Again, Dale, thank you for coming on. We'll definitely have to come back for something. Like I said, we're going to try to get at least 3 episodes out of you. So, and we'll figure that out later. But anyway, that's it for everybody, for all us here for this week. Check out the Patreon. Check out the Teespring store. Check out all the different discounts we have for rodents, Cold-Blooded Cafe, Cold-Blooded Caffeine, and that's it. So thanks everyone for listening, and we'll catch everybody back here next week for some more Morelia Python Radio. Good night.